Been told to keep doing my stretches, so I'm sure, to stay healthy. I'm sure this is not entirely what people meant. Keep doing the stretching. I'm doing the best I can. That's rubbish. Let's just check this is still working. Check it. Yeah, that's working. Okay, so we're all healthy. That's good to know. We're going to learn about Ohm's law and the reason that we're going to use Tinkercad and learn about Ohm's law so we can stop blowing things up. You would have got yourself to here by going to the Learn menu there, and we're going to do two more things to get to the Ohm's law lesson that we've explored slightly before. We go to the 3D tab and we drop down to go to circuits. So Ohm's law in circuits. It's not there straight away, and that's because we're in starters. We're going to move to lessons. And when we get to the lessons, this is the one that we want. So we're going to just look at Ohm's law. And one of the things that we're doing is going to simulate how to use a meter, a multimeter, to look at how to measure the current, the flow of electricity in a circuit. And one of the things is because we're looking at components and how to make sure we don't actually blow them up. So, this one, that speaker, that works and it's not blowing up with a 9-volt battery cell, which is great. So if we did the same with LED, which you've seen before, there's the LED, you know that we use 3 volts for this sort of LED. If we added a 9-volt battery to it, it would blow up. And so what I'm going to show you how to do is to use a resistor and changing the resistor values here to help protect components in your circuits. So what you have here is a circuit directly connected to a 9-volt battery. We would expect it to blow up. We start the simulation of the circuit, it blows up. We can hover the cursor over the exploded LED and we can see that the value here, 915 milliamps, is how much current is flowing through the LED, and it's going to burn up. So what we'll do is we'll build a circuit next to it. We'll do that so that we can put a meter onto it. We can actually measure that. So let's build a new circuit here. Take the 9-volt battery. To help us out here, what we'll do is rotate it. We can go to the rotate, and then when we click and drag, gives us a little bit more space. We're going to be working with an LED, so we'll drag the LED to the circuit. We're also going to use a resistor, so we'll put a resistor in the circuit as well. And also to measure and to use, I don't know, where did I throw it? The multimeter with the wires, to attach the wires. To do this in Tinkercad, the device we use is a multimeter, and it's all the way down at the bottom here. And click and drag, and we'll put that into our circuit as well. So remember, and we're going to remember with that drop down for the multimeter, we're measuring current, the flow of amperage through the circuit. So we click onto it for the amperage. Okay, so we are going to have to wire this up in some clever sort of way as well. We'll start with going here. We'll take the negative side and we'll click. We'll start so that we can navigate our way through and make sure that we've got the colours the correct way round. I don't think it matters quite so much which way round for current. It's going to be for the wires. In fact, because it's just measuring the flow. But we're on the negative side of the circuit, so we'll keep doing it on the negative side of the circuit. And remember that the LED will only accept the flow of current through itself in one direction. So now we'll connect the anode side. Click, click, click. If you can, keep it as neat as you can so that you can see what's going on. And that's the positive side of the circuit. So now if we start the simulation here, we get, okay, what's different this time? Wonderful, is that the LED here has not blown up because we've put a resistor to restrict the flow of current through the circuit. Unlike this one, where it does blow it up. So that's simply the idea of the lesson. You can see and measure the different flow in the circuit by using a resistor. And what we'll know is that the amount of flow changes with the resistor value.